Okay, so let's talk about how you graph a tangent function. So the things you have to recall is that your tangent function on your unit circle is the y value over the x value. Now, our y value is our sine, our x value is our cosine. So the first thing I would like you to do is I would like you to look at where the x values, which are our cosine values, hit 0. Now the cosine is equal to 0 at the pi over 2's, the odd pi over 2's. So that means that when that tangent is at the odd pi over 2's, it ends up getting a 0 in the denominator. So at those spots on the graph, we end up having vertical asymptotes. So at all of the odd pi over 2's, you will have a vertical asymptote. Now let's think about where the y is equal to 0. That happens at all of the full pi's. Where the y is equal to 0, our function itself will be equal to 0. Now you'll notice that doesn't give us a whole heck of a lot. So that doesn't give us a whole lot of information. So we need more information. So one thing we can think about is that the tangent of pi over 4, or 45 degrees, is equal to 1. So we know over here we're equal to 1. So to the right of every one of these zeros, we're going to be equal to 1. Because of our rules of coterminal angles, it's going to flip back around. The tangent of negative pi over 4 is equal to negative 1. So it's negative 1 over here. What we end up getting is kind of some interesting things that occur. We end up getting these things.
Excuse this interruption.
Like
Hubbard
cubics.
students may now be released. That's all Hubbard students. You may be released at this time. Thank you.
The 5 points that we dealt with quite a bit. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Don't give us a lot of information, but they give us enough. Because at 0, we have a 0, then an asymptote, then a 0, then an asymptote, then a 0. So the 5 points we would plug in for a sine and a cosine, we can plug in for a tangent, but remember, it only gives you the zeros and the asymptotes. So now let's look at the actual properties of our tangent function. So here we go. So the domain of this function is everything but no odd pi over 2's. All the odd pi over 2's just don't work. they give us asymptotes. So technically, our domain, our continuity, and asymptotes are pretty much saying the same thing, that the pi over 2's don't work. So those will go hand in hand. The range is all real numbers. Everything works. The x-intercepts are the full pi's. So 1 pi, 2 pi, 3 pi, 4 pi, negative 1 pi, negative 2 pi, negative 3 pi, negative 4 pi. The y-intercept is 0. The only place we hit the y-axis is at 0. The symmetry is odd. So what we know about odd functions.
Excuse this interruption. All students that are picked up in the back of the building may be released at this time. That's all students that are picked up in the back of the building may be released at this time.
Parents pick up?
I mean, my grandpa picks me up from the side, so
Yeah.
I don't see how that makes a difference.
I don't know. So the symmetry, it's an odd function. There are no maxes and mins. These are just like cubic kind of functions. Just a minute, I'll get it back on this. It keeps being stupid. There we go. Okay. The period for a tangent function is pi, not 2 pi. So when we go to figure it out, again, just take that bx term, but this time don't set it equal to 2 pi, set it equal to pi, and divide by b. What's the date today? I have no idea. So now let's go ahead and look at our first example. So we're going to look at an example.
You still got 3, huh?
3
I got
left.
none- I got none left.
So there you go. Roads must be yucky.
What is it? Weathersfield just pulled in.
Oh, okay.
You probably
She
wait-
could have gone, but she's a good kid, wanted to learn something, so.
You know, you wanna hold on to that guy.
Yep, exactly. So now let's look at our first example, dealing with a tangent. Huh? Kinda crazy. I'm trying to teach it, and it's like. I'm gonna go, I'm taking a video of it, so. So now, let's take a look at this. Now, think about normally. If we would look for the period of that, we would set that equal to 0. We would cross multiply over, multiply by 3, right? So we're gonna take, and you need a lot of room, because we're gonna have an x, we need a cosine, no, let's put a sine first. We need a sine, we need a cosine, we need a tangent. So normally, our values, 0, pi over 2, pi, 3 pi over 2, and 2 pi, we're going to multiply all those values by 3. So it's going to be 0, 3 pi over 2, 3 pi, 9 pi over 2, and 6 pi. And I'm going to take my x's, and I'm going to change them. I'm going to multiply them all by 3. So I'm going to make this 3 pi over 2. I'm going to make this 3 pi. I'm going to make this 9 pi over 2. And I'm going to make this 6 pi. I'm going to do that in the opposite direction too. Why not make the graph paper match what we need to accomplish? Now let's think of our sine values. Our sine values go 0, 1, 0, negative 1, 0. Our cosine values go 1, 0, negative 1, 0, 1. To find our tangent values, let's just think about the fact that we need to divide them. So 0 divided by 1 is 0. 1 divided by 0 is undefined. 0, undefined, 0. It should go in either a pattern of 0, undefined, 0, undefined, 0, or the opposite, undefined, 0, undefined, 0, undefined. And that's usually what happens for your cotangent. It should reverse that. Let's put all of our asymptotes on. There's an asymptote at 3 pi over 2. And 9 pi over 2. So going the opposite direction, negative 3 pi over 2 and negative 9 pi over 2. Our zeros occurred at 0, 3 pi, and 6 pi. And so so negative 3 pi and negative 6 pi. And our tangent curves go one to the right and negative 1 to the left. And so they look like that. So that's how you would graph a tangent function. You really need to look at what the sine and cosine do, and that will help you find what the tangent is doing.
Excuse this interruption. Lordstown may be now be dismissed. Lordstown students may now be dismissed. Thank you.
Not even-
At this point, if I get dismissed, I'll be like, nah. It's like 10 minutes, I don't care.
Now let's look at our cotangent. Our cotangent is x over y. So here's our x, here's our y. So first let's look at our y values. Our y values are 0 at the full pi's. So let's go ahead and put asymptotes there. So there are asymptotes at the full pi's. The x's are our cosine. Let's look at where the cosine is 0. The cosine is 0 at the pi over 2's. So that means our function is 0 at the pi over 2's. Now we said earlier that the tangent of 45 degrees, or pi over 4, was 1. So the cotangent is just the reciprocal of that, and if I reciprocal 1, I'm still going to get 1. So over here at 45 degrees, I'm actually up at 1. It actually puts the negative 1 on the other side, so it flips it over. Hence the reciprocal, if that helps you to remember that it got flipped over. So the tangent function, it looks like the tangent function has been pushed to the side and flipped over. So this graph goes 0, pi over 2, 0, no, sorry, 0, pi over 2, pi, 3 pi over 2, and 2 pi. And the y values go undefined, 0, undefined, 0, undefined. Let's write down the properties, and we'll do an example of these, and then we're done. Here are the properties. The domain says that we cannot have a full pi. So 1 pi, 2 pi, 3 pi, 4 pi. Negative 1 pi, negative 2 pi, 0 pi. And remember, the domain, continuity, and asymptotes all go together. So they all mention the fact that we cannot have a full pi. The range is still all real numbers. This time the x-intercepts are at the odd pi over 2's. Do you see how our domain and our x-intercept, they flipped around? The the tangent is the exact opposite of that compared to what our cotangent is. There is no y-intercept because there happens to be an asymptote there. There is no extrema. There's no max and min. And the symmetry is still odd. So the cotangent of negative x equals the negative cotangent of x. Let's look at our last example for today real quick. Let's look at example 3. You'll notice that we have a change in amplitude. So how would we solve for x if that was, say, equal, let's say it was equal to 2 pi. How would you solve for x? You divide by 2. So we're going to take all these values that are down here. Let's divide them all by 2. So let's make that pi over 4. Pi over 2, 3 pi over 4, and pi. And I'll go the opposite direction. So we're going to make a chart. It's going to need an x, an x. It's going to have a cosine of x. Well, it'd actually be the cosine of 2x. We'll just write cosine. Then we need a sine of 2x, and that will help us get our cotangent. Okay? So our x's are going to be 0, pi over 4, pi over 2, 3 pi over 4, and pi. We know the pattern for our cosine is 1, 0, negative 1, 0, 1. We know the sine pattern is 0, 1, 0, negative 1, 0. Now remember the cotangent is x over y. So we're just going to divide those and to find our cotangent. So it's going to be undefined, 0, undefined, 0, undefined. All of our undefined values, those find our asymptotes. So let's put those on. There's an undefined at 0, undefined at pi over 2, undefined at pi. And we could go the opposite direction. We have zeros at these pi over 4 values. Now remember, our cotangent graph is the flip of the tangent. If that helps you remember that, then we know that our graph goes like this. And we just put them all on. So that's how we graph a cotangent. that good for everybody? Does anybody have questions? The assignment that's gonna go to this, if you flip down a few slides to your assignment page, the assignment that's gonna go to it is just 1, 2, 3, 4, and 33. Could you please change number 3? Instead of pi over 6, could you make it pi over 2? It'll just make your life so much easier. So please, for number 3, could you please change that to x minus pi over 2? This is gonna be due on Wednesday. Part 1 is due on Wednesday. I'll let you know about part 2. It might be due the same day. We'll just kind of wait and see.